Let's talk about radians. So radians are just another measure for angles. The whole non-mathematical world uses degrees to measure angles. So like 90 degrees, 180 degrees. Radians is another unit that you use to measure angles, and it's kind of the correct unit to measure angles in because all these trig functions are defined in terms of radians. So anybody who actually uses math involving angles, so engineers, scientists, mathematicians, they always think in terms of radians, and I want you guys to make the transition to thinking in terms of radians. So this is the first step. All right, so what is there to know about this unit of radians? So just like there are 360 degrees in a full circle, there are a little bit more than 6 radians in a full circle. There's a little bit more than 6.2 radians in a full circle. And there's more to this story in just a second. But I want you to think naturally in terms of numbers that make sense to you first. So if you think about there's about 6 radians in a full circle, if I asked you what is the sine of 1, you're not thinking 1 degree, which is like a very small angle, and the sine would be just slightly larger than 0, because the y-coordinate is slightly larger than 0. Instead, you're thinking, 1 radian. So if there's about 6 radians in a full circle, where would 1 radian be? Well, it would be a sixth of a circle, which is kind of here-ish. And so if I ask what is the y-coordinate there, the answer is it's almost to 1. So if I was just going to, like totally estimate, based on almost nothing, I would say it's about 0.8. Oh, actually, I was not too far off. It's 0.84. I just looked it up. Okay, so when I said that there is about 6.2 radians in a full circle, that's a little bit misleading. Actually, there are 2 pi radians in a full circle. But remember, pi is like approximately 3.14. So if you multiply that by 2, that's where I got my approximately 6.2. So that's the main thing that you need to remember. So if you wanted to know what is 17 degrees in radians, it's just a basic unit conversion. You could set it up the same way that you would any unit conversion. You've got 17 degrees and you want to multiply it by some number of radians divided by some number of degrees where those are the same. So I know that in 360 degrees, there are 2 pi radians, and that's going to give me the unit conversion because the units of degree is going to cancel with the units of degree, and that'll give me radians. So, that's something that you could do anytime. But there's really only several standard angles that you use a lot. And so those ones are ones that you're going to want to memorize. But it's actually very easy to memorize them, and I'll show you how. Let's pretend that this is not a terrible circle. Actually, hold on. All right, well, it's still pretty terrible. So let's say you want to know what 45 degrees is. There's a really easy way to do it. I know that a full circle is 2 pi radians. So what's a half circle? Must be half that. So that must be pi radians. So that's like 180 degrees. All right, what's half of that? Must be pi divided by 2, because I divide it by 2. And so 45 degrees is half of that, so if I divide it by 2 again, that gives me pi over 4. So that's the approach that I want you to take. Always start with a full circle, and then just divide until you know the size of whatever slice you want. What if you want to know this angle? Well, it's easy. You just divide until you get a slice, and then you add up the slices. So half of 2 pi is pi, half of that is pi over 2, half of that is pi over 4. So I know that's the angle of this slice. And then to get over here, I need 1, 2, 3 of those slices. So the angle all the way to here must be 3 pi's over 4. So let's do one more. So again, we have to pretend my drawings aren't terrible. Let's pretend I've divided the upper half of this circle into 6 slices with even angles. So what would the angles be for each of these different endpoints here? Well, easy. So 2 pi is a full circle. Half of that is pi. Half of that is pi over 2. So I already know what this one is, pi over 2. I want to divide this pi over 2 into 3 equal parts. So pi over 2 divided by 3 gives me pi over 6. And so that's this angle. If I have 2 of them, that's 2 pi's over 6. But clearly that simplifies as pi over 3. And then if I have 3 of those, that's 3 pi's over 6. But 3 divided by 6 simplifies as 1/2. So that's why we get pi over 2. Here it would be 4 of the pi over 6 distances. So that's 4 pi over 6, but that simplifies as 2 pi over 3. Here I have 5 pi over 6. And then here I've got 6 slices, so it would be 6 pi over 6, which is the same as pi, which makes sense because we know that that's half of the full circle of 2 pi. So again, that's the idea. You can do it very quickly mentally just by dividing to get a basic slice and then adding up how many of the slices do you have. So you should spend a while drilling yourself with pictures like this, and you can ask for different basic angles, what would they be in radians? So I know that this is pi, but it's also 6 pi over 6, so this must be 7 pi over 6, because I've added one more pi over 6. All the way around is 12 pi divided by 6, because it's the same as 2 pi. So 12 pi divided by 6 minus a pi over 6 must be 11 pi over 6. So again, you can like practice with the mental math in terms of the basic unit of pi over 6 as your slice.